You may have noticed in the last couple of examples we didn't get very precise with how we're drawing our hyperbolas. So we're going to add a detail to help us make our hyperbolas even better. So each hyperbola has two things called an asymptote. We've dealt with asymptotes before. We've never really dealt with asymptotes quite like this. These two asymptotes intersect at the center of the hyperbola. So wherever the center is, those two asymptotes go diagonally through that. Now the asymptote passes through the vertices of a rectangle with the dimensions 2a by 2b. Now what that, if you're kind of trying to visualize that, this side length here, this whole side length from here to here would be 2a, and this side length, oh sorry, that'd be 2b. And from here to here, that'd be 2a. Honestly, we're not going to deal with that a ton, but that's just something that's kind of convenient. The line segment of length 2b is called the conjugate axis of the hyperbola. So this section right here is our conjugate axis. Now, the more important thing, in my opinion, is the asymptotes calculations. So the equations we're going to use are, the equations of the asymptotes are y equals, let me zoom in, k plus b over a times x minus h if we have a horizontal transverse axis. And it's going to be y equals k plus or minus, sorry, I forgot to say that one, plus or minus, because there's two of them, a over b times x minus h. So this example here, we're asked to find the center, the vertices, the foci, and the equation of the asymptotes of the hyperbola with the following equation. We have x squared over 9 minus y squared over 25. This is going to be a horizontal because the x group comes first. So it's horizontal transverse axis. Now this one, our center, is going to be nice and convenient. You might remember this from our original definition for the hyperbola equations. Our center is at 0, 0. Remember, it's x minus the h value, which is x minus the x coordinate of the vertex. Well, it's x squared, so it's just x minus 0. Same thing for the y. Now, our a and b values. Our a value, well, a squared is 9, therefore a must be equal to 3. B squared is 25, therefore b is equal to 5. Now, to find our vertices, let me actually plot this 0, 0 point before I forget. So we got that point 0, 0. Our vertices, since we're dealing with a horizontal transverse axis, it's going to be changing the x values because it's on a horizontal line, so the x values are the ones that are going to change. So it's going to be 0 plus or minus that a value of 3 in order to leave the y value alone. So our two vertices are going to be at negative 3, comma 0 and 3, comma 0. Put those on the graph. There we go. There's one vertex. There is another. Our foci, we're going to need to find our c value. Now, we haven't done that yet. Remember the equation c squared equals a squared, and for hyperbolas, it's plus b squared. We got c squared equals a squared is 9, we already knew that, plus our b squared, so plus 25. We end up with c squared equals 34. And we take the square root of that, and we end up with c equals, well, the square root of 24. Square root of 34. It's not a perfect answer, but the square root of 34, we are going to need an approximate answer for that in a little bit, so let's just calculate that. The square root of 34 is about equal to 5.83. So our foci are going to be, take the x coordinate 0, add that plus or minus the square root of 34, so plus or minus about 5.83. Sorry, waiting for your server to catch up. And then our y coordinate is 0. So our two coordinates, we're going to have one at negative 5.83, comma 0, and the other one's going to be at positive 5.83, comma 0. And again, those are not perfect points. We're going to approximate them. Negative 5.83 I'm going to put there. Positive 5.83 we're going to put there. Now, this is kind of where we left off in the last couple examples. Now we can do a little bit better, because the last couple examples, I just did very poor, kind of parabola-looking things. That's not what we're looking for in this one, because we can get asymptotes out of this. Now, our asymptotes are going to follow those equations that we have up here. So, since we have a horizontal transverse axis, we're going to use that top equation. So, we're going to use y equals k plus plus or minus b over a times x minus h. We have all of that info. Now we just got to plug it in. So our k value was the the y of our vertex, so it's 0 plus or minus b value we got was 5 over our a value, which was 3, times x minus 0. So, sorry, I keep reading the plus or minus. My apologies. So it's plus or minus. Now, I'm going to ignore the 0 there. We got 0 plus whatever. It's just going to be the rest of it. 5/3 times x minus 0 is just 5/3 times x. So we have 5 over 3 times x. Which means it's going to go through our vertex, and it's going to go up 5 over 3. Up 5 over 3, and there's a point on that asymptote. Sorry. Up 5 over 3 again. Oh, my goodness, I'm having a hard time drawing. Up 5 over 3 again. And we can also take that line and go in the opposite direction. So we can go down 5, 3 to the left. Down 5 more, 3 more to the left. And I'm going to draw this on with a that's supposed to be a straight line. With a highlighter. Because remember, this is not actually part of the graph. This is just a reference. Now, we also have the negative 5/3 x. So if it helps you to break this down into y equals 5 over 3x, so a slope of 5 over 3, we just did that one. And also y equals negative 5 over 3 times x, sorry. To kind of give you a visual. The other one's going to have, it's going to go through 0, 0, but we're going to go down 5 over 3 to the right and repeat that process. Down 5 over 3. Same thing on the left side will be up 5 over 3 and another up 5 over 3. And so this line is going to go, this asymptote is going to go look something like that. Now from here, we have enough points that we can actually draw these branches of the hyperbola. Now let's focus on the right side here, pun partially intended because we have foci here. But we're going to get, this curve is going to get really, really close to this asymptote. I'm going to draw it nice and slowly. It's going to get really, really close to that asymptote. It's also going to get really, really close to this bottom asymptote here. Same thing on the left one. This part's going to get really, really close to this asymptote. And this part over here is going to get really, really close to this asymptote. So this is a much better representation of a hyperbola than we had on the previous examples. Now we can make it a little bit more accurate. Is it perfect? No. But if you want to get more exact points, you can plug in points. Like maybe you could plug in x equals 4 and see what point it gives us there, and x equals 5 and see what point it gets there. But for the purposes of this problem, of what we're doing right now, this is perfectly fine. Let's try another example like that. We're asked to find the center, the vertices, the foci, and the equations of the asymptotes for the hyperbola with the following equation. We got y plus 2 squared over 4 minus x minus 1 squared over 16. This is a vertical transverse axis. Transverse axis. And in this case, you can identify it because the y group comes first. Now, in this case, we do have a center. It's in here. The y value comes from here. The y value is going to be negative 2. Remember, it's the opposite of what's being done. Our x value is positive 1. A, in this case, is going to come from this. It's a squared is 4, therefore a is 2. B squared, the other denominator, is 16, therefore b is 4. And finally, let's just find c while we're at it. So we got c squared equals a squared plus b squared. So more like the Pythagorean theorem than we were dealing with the ellipses. So we got c squared equals a squared we already know is 4. B squared we already know is 16. So we have c squared equals 20. Now, when we take the square root of both sides, unfortunately, 20 is not a square number, but we can break it down into the square root of 4 times the square root of 5, and we can clean that up just a little bit more and make it 2 square roots of 5. Okay, now we've got everything we need to find our vertices, to find our foci, to find our equations. Let's start by plotting that point at 1, negative 2. So we'll go 1 to the right, negative 2, and this is our center. Now, to find the vertices, since we have a vertical transverse axis, that means our y-coordinate is going to be the one that changes. So we're going to leave the x-coordinate alone. We're going to take the y-coordinate and add and subtract the a value. So we're going to say plus or minus 2. So that means we're going to get 2 of them. When we subtract 2, we get 1 comma negative 4. When we add 2, negative 2 plus 2 is 0. So we have 1 comma 0. So let's plot those two vertices again. 1, -4, so down here, and 1, 0. So that's a vertice and that's a vertex and a vertex. Our foci, we're going to have, let's see, leave the x coordinate alone. So we have 1, and then we're going to change the y coordinate. We're going to do -2 plus or minus 2 square roots of 5. Folks, you can just type that into a calculator. You're going to get 2 points. One of them is going to be approximately, well, let me just write out what we're doing first. We have 1 comma -2 minus 2 square roots of 5, and the other one's going to be 1 comma -2 plus 2 square roots of 5. Now from here, I would suggest typing that into a calculator. We're going to end up with 1 comma about 2.4, sorry, I'm doing that one wrong. I was looking at the other one. Let's do -6.47, and the other one, -2 plus 2 root 5, is going to be approximately positive 2.47. So when we plot those on our graph, we're going to do our best to make it as close as we can. 1 comma -6.47, that's like a little less than halfway between -6 and -7. And 1 comma 2.47, that's a little less than halfway between 2 and 3. So we got to focus there. We got to focus there. Now for our asymptotes, the equation, we're dealing with a vertical transverse axis. So our equation is going to be y equals, k plus or minus a over b times x minus h. All right, sorry. Just going back to our center, that's where we get our h and our k from. So our k is -2, so we have y equals -2. And then plus or minus, our a value was 2, our b value was 4, that'll reduce nicely, times x minus our h value, which was 1. Let me zoom into this a little bit. We got y equals -2 plus or minus 2 over 4, that's 1/2, times x minus 1. Folks, from here, I would separate this out. Let's do one equation where it's y equals -2 plus 1/2 times x minus 1, and we can clean that up in a second. The other equation will be y equals -2 minus 1/2 times x minus 1. The reason I'm having us split these up is we're going to distribute this 1/2, or in some cases, the -1/2. So we're going to distribute that that 1/2 into the x and to the -1. So we have -2 plus 1/2 x, and then 1/2 times -1 is going to give us -1/2. So that's going to be one equation. But we're going to clean that up a little bit more. Putting it in standard form, we got y equals positive 1/2 x, and then we have -2 minus 1/2 gives us -2.5, or -2.5. Over here on the other equation, we got y equals -2, and then we're going to take the whole -1/2 and distribute it. So we got -1/2 x, and then -1/2 times -1 is going to be plus 1 over 2. So when we can combine this, we got -1 over 2 x, and then we have -2 plus 1/2, that's -1.5. So using that information, we can draw draw the two, my goodness, what's the word I'm looking for? We can draw the two asymptotes. Now, we have this set up so that we actually have the y-intercepts, which is kind of nice. But one thing, you actually don't really need the intercepts. Once you figure out what the slope should be, if you know the center, you can just go based off of that. But let's draw these out. So we have one y-intercept at -2.5, so that's going to be right there. And it's got a slope of 1/2. So if we go up 1/2, up 1 over 2. So we'll go up 1 over 2. It's going to go through here. And really, we're just going to have a slope of 1/2 going through these points forever. Now, same thing, the other one's got a slope of -1/2, so we can, like, if you want to start from the center, to go down 1 over 2, down 1 over 2, and you can just repeat that process. And we're going to have another asymptote going through these lines, or these points. And from here, we can just approximate the rest of this hyperbola by starting at the vertex and just getting really close to the asymptote over here. And we're going to get really close to that asymptote over there. trying to make it so that it gets closer and closer and closer as it goes on. Now we're human here. We're not going to be able to draw this perfectly, but our graph's going to look a little something like this. So again, for the asymptotes, whether you're using the official y-intercept, like in this case, I kind of skipped over the 1/2, but it'd be right there, or just use the center and use the positive and negative versions of the slope, whatever works for you is perfectly fine.